Okay, so a curve is described by the equation here, find dy dx in terms of x and y. Okay, so this is just like C3, implicit differentiation, but there's a bit more to it, right, when it comes to the part B's and C's. So we need to take heed on that. But just go through this now in terms of the process, okay, of implicit differentiation. Remember, there's product there, yeah? Functions times it together. Well, you got to do the product rule. Okay, so v is 4x. U is 4x, v is y. So du dx is 4 dv dx. Then differentiate that. That becomes 1 times dy dx. Okay, and then do the product rule. This times this. This times this. Okay, so that would be 4y plus then 4x dy dx. Yeah, because you do v du dx plus u dv dx. So then differentiate this implicitly. This becomes 2x. Okay, this then we've done over the other side there. Already differentiated it. Y squared becomes 2y dy dx. 27 is 0, and then you've got that equals to 0. Okay, and then just to what we do then is factorize the dy dx's. Take the other rubbish over the other side, other terms over the other side, and then dy dx equals minus 2x minus 4y, and then divide by all that stuff there, right? 4x plus 2y. Now, I wouldn't leave it like this, right? Because, we should really be looking at simplifying this down, because you can see here, they're all even, aren't they? So we can take out a factor of 2 on the top. In fact, we could take out minus 2 if we were really clever, right? But, it's up to you. You could just take 2 out if you wanted to, okay? But I'm going to take minus 2 out. And minus 2 times x gives me this, and minus 2 times plus 2y will give me minus 4y. All over there. Now take 2 out on the bottom, okay, and the 2's then will cancel, okay, so you end up having minus x plus 2y in a bracket, of course, because the minus applies to it, and then 2x plus y on the bottom, okay. Now, that's it, right? That's your part A done, right? And then your part B then, right, takes things a little bit further sometimes. So what does it say here? Point Q lies on the curve. The tangent to Q, to the curve at Q, is parallel to the y-axis. Okay, given that the x-coordinate of Q is negative, use your answer to part A to find the coordinates of Q. Okay, this is important. When this is the tangent to the curve, right, is parallel to the y-axis. Okay, well, basically, your curve. Okay, I don't know what it looks like. Okay, it doesn't matter. I'm just going to draw a scrap drawing here of a curve. And of course, my tangent then, right, would be, I've got a ruler here, let's just use this, right? My tangent, say at that point, so you say that point is Q, right, is meant to be then parallel, okay, in my rough sort of way, parallel with the y-axis. And of course, it's parallel to the y-axis, we've got to ask ourselves, what's happening to dy dx? What's happening to the gradient of that line, right? Well, of course, if you think about it, because it's vertical, the gradient's like infinity, isn't it, right? Because the slope is just mega, isn't it? You're falling there, right, in terms of the gradient. So basically, at Q we can say dy dx, right, will just go to infinity, okay, right? So then this goes to infinity, and you might wonder, well, what on earth do I do now? But if this goes to infinity, think about it. That means then the bottom will actually equal 0. Does that make sense? Because remember, when you divide by 0. This is math error and you calculate it, it goes to infinity, okay, and that's what kind of happens here, right? This actually goes towards 0, so we could literally say, therefore, 2x plus y equals 0. So we set the bottom equals to 0, okay, that's so important. Now another question, right, might ask, it might say the tangent is parallel to the y-axis, okay, now this would be an alternative situation where tangent is parallel to the y-axis. Well then, what would you set dy dx to equal then? Well, of course, in that case, dy dx would equal 0, wouldn't it? Okay, and if dy dx equals 0, you'd actually set the top to be 0, okay? So that could come up as well. But in this case, this is what's going on, right? The tangent is parallel to the y-axis, so you set the bottom to equal 0, right? You've set the bottom to equal 0 because dy dx goes to infinity. And if that's the case there, well, we can get y in terms of x, right? Just take that 2x over. It's really simple, right? And it says then to find the coordinates, okay, of Q. What you do then is, because we know this is true at Q, right? what we do then is we sub this back into our original curve, which is way up here in the question, right? So we sub it in. So we just say, look, sub into C, is it? I think that's what they call the curve. So we've got x squared, okay, plus then 4xy. Now remember, y becomes minus 2x, that's what we're subbing in, plus then y squared. Okay, so there you go, there's y squared, plus 27 equals 0. This is then x squared. Now this becomes minus 8x, okay, squared, because 4x times 2x is 8x squared, minus, of course. This then becomes, because there's a minus there, but you square it, it becomes plus, doesn't it? 4x squared plus 27 equals 0. Work all this stuff out here, right? I hope this comes out nice. Hope I've done it right. X squared minus 8x squared plus 4, so 1 minus 8 is minus 7, plus 4 is minus 3, x squared plus 27 equals 0. This means then you get 3x squared equals 27, right? This is looking good, isn't it? So then x squared will equal 27 over 3, so then x squared will equal 9, which means x equals then plus or minus 3, sorry, plus or minus 3, isn't it, when you square root it? Okay. And then, what does it say in the question? Does it not say x coordinate of q is negative? That's just says, isn't it? X coordinate of q is negative. So since x is negative, x will equal minus 3. And then to get y then, right, to get y, all you've got to do is go back to this up here, okay? So y would equal minus 2 times minus 3, which equals to positive 6. So my coordinates of q is minus 3, 6, and it's all done.